This is an excellent but complex problem that demands you understand a lot about um, derivatives and particularly the fundamental theorem of calculus part 1. So, and it is a calculator problem. So you're allowed to use you're allowed to use a calculator. In fact, you're going to need a calculator to solve this problem eventually. The figure above the graph, figure above shows the graph of a differentiable function g and the line tangent to the graph of g at the point 5, 2. So we know that we have a point right here, and that is the point 5, comma 2. It says f is the function given by f of x is equal to the integral from 0 to x g of t dt. Now, I'm going to tell you from an AP test standpoint, when I see something like that, like from a constant to the variable, I'm thinking first fundamental, the fundamental theorem of calculus part 1. And what I'm thinking right off the top, even if I might not need it, I'm thinking that f prime of x, well, let's actually write it a little bit differently. Let's write it this way. This will be a little bit better here. I'm going to write, I know that f of x is equal to the integral from 0 to x g of t dt. So that means that the derivative with respect to x of f of x, I'm going to take the derivative of both sides. Well, the derivative of f of x, I'm going to call it f prime of x. That's all it is. But this is going to make use of the fundamental theorem of calculus part 1, because this means that the derivative of the integral is the function. So f prime of x is equal to g of x, and that is a key piece of information that we're going to need. But let's continue reading the problem. Really, I should have finished reading the problem before I started that, but I'm impatient. Let h be the function with the first derivative given, and they give us the formula for the first derivative. And it looks kind of ugly, and that's really why we're going to end up having to use the calculator. And that's from 0 to 7. Here's the complicated sentence. If the line tangent to the graph of h at x equals a is parallel to the line tangent to the graph of f at x equals 5, what is the value of a? That is a complicated sentence and requires some thought. Well, it says the line tangent to the graph of h at x equals a is parallel to the line tangent to the graph of f at x equals 5. Well, the line tangent to the graph of h at x equals a means that h prime, that is the slope of the line tangent to h prime of a is going to be equal to f prime of 5, because they are parallel. So I know that the slope of the line at h equals a is parallel to the line tangent to the graph of f at x equals 5. So the line tangent to the graph at x equals 5 is f prime of 5, and the line tangent to the graph at x equals a for h is h prime of a. So I know that these two things are equal. Well, I also know that f prime of x is equal to g of x. So let's kind of go back up here. So then if f prime of x is equal to g of x, that means that f prime of 5 is equal to g of 5. Well, let's kind of take a look back up here at our graph. G of 5 is 2. And in fact, they even tell us in the problem here that I have on G, I have the point 5, 2. So it's telling me that G of 5 is equal to 2. So I know that f prime of 5 is equal to 2, which also tells me that h prime of A is equal to 2. H prime of A is equal to 2, because f prime of 5 is 2, f prime of 5 is 2. I hope you can see that. So an easy mistake to make right now would be to say, well, then what is h prime of 2? This is a mistake because it's not asking what is h prime of 2. It's telling me that h prime of A is equal to 2. So I have to get my calculator out. And I've entered the equation of h prime. And I'm going to check it. First, I'm going to check my mode to make sure I'm in radians. And I'm in radians, so that's good. So I'm going to go zoom 6, and I'm going to get what that function looks like. That's the function of h prime. But it only is asking me from, what was 1 to 7, I think, wasn't it? No, from 0 to 7. So I'm going to just make it a little bit easier on myself, and I'm going to change my window, and my x min is going to be 0, and my x max is going to be 7. So the only thing I'm seeing on my screen is from 0 to 7, and once I change my window, I have to press graph to get the picture. So this is what it looks like from 0 to 7. And again, looking at the what the question is asking me, it's not asking me for h prime of 2. It's asking me what value of A, that is what x value, will have a y value of 2. So I'm going to go back to my calculator, and I'm going to enter in another function, which is simply y equals 2. And I press graph, and I see my first one and my second one. And what I want to know is what is the x value where these intersect, because this will be the x value on the blue function, which is my h prime, that is equal to 2. So I'm going to go second, and above trace it says calc, and I'm going to look for an intersection. That's number 5. And it says, well, your first curve, the blue one, y equals x squared sine x over 3. Yes, that is my first curve. So I'm going to say yes. And is your second curve the red one? It's got a little cursor on it right there. I'm going to say yes. Do I want to make a guess? No, I don't want to make a guess. That's why I bought the calculator, so I don't have to guess. And I press enter, and I find out that the x value where y equals 2 is 1.856. So I'm going to write that down over here. A equals 1.856. And I'm going to kind of go look at my my options, because I didn't leave the, I didn't have enough room here. And lo and behold, B is 1.857, and that is the correct answer.